Okay, I think it started recording already.
I think it did too.
Usually shows me a little countdown.
Oh, we're your video class today?
All right, so this is section 7, topic 3. And it is called Solving Systems of Rational Equations. All right, first example. Consider the following system of rational equations. I have f of x equals 3 divided by the quantity of 2x minus 5. And I have g of x equals 2 divided by the quantity of 2x plus 3. And the directions say for what value of x does f of x equal g of x? So these are two functions. We have function f and function g. And if we put them both on a graph, if they intersected, we would want to know at what point do they intersect, okay? So those ordered pairs. We've done this with lines before. Where do these two lines intersect, if they do? We've done it with a line, one line, and a parabola, or two parabolas, okay? Well, now we're gonna find out where these rational equations intersect. So we're finding ordered pairs. On some of the directions, it just wants you to find the x value of the ordered pair. Like in this case, it just says for what value of x does function f equal function g. Sometimes it's going to want you to find the whole ordered pair. Okay, so just depends on what the directions say. So basically, we're just solving for x. I want to know when does function f equal function g. And I taught y'all how to do this when we were doing systems with quadratics. We did the same method, okay? So function f, we are going to substitute in 3 divided by the quantity of 2x minus 5. And we're going to set that equal to function g. It's equal to 2 divided by the quantity of 2x plus 3. So we just use substitution right there, right? This is a rational equation. We just learned how to do rational equations last class, and we just went over homework with rational equations. So remember, the first thing we want to do is we want to clear the fractions. So we multiply every term by the LCD. Well, before you do that, look at the denominators. Can either of those denominators be factored? No.
No.
Okay, so that makes it kind of easy. So my least common denominator is 2x minus 5 and 2x plus 3. So I'll multiply every term by 2x minus 5 and 2x plus 3. Then we cancel where we can. So 2x minus 5 and 2x minus 5 cancel. On the right side, 2x plus 3 and 2x plus 3 cancel. And then we see what we have left. So on the left side, I've got 2x plus 3 times 3. I like my monomial to come first. So I'll rewrite that as 3 times the quantity of 2x plus 3 equals. On the right side, I have a factor of 2 and 2x minus 5. So we'll multiply those together in the next step. Remember, my goal is to solve for x. Try to figure out what x is. So what do you think I do right now? Distribute. So 3 times 2x is 6x. 3 times positive 3 is positive 9. Equals 2 times 2x is 4x. And 2 times negative 5 is negative 10. Now, can I solve for x just by isolating x, or am I going to have to get it set equal to 0 and in standard form? I'm going to solve for x, right? There's nothing to combine on the left or the right, so I can start moving stuff over from one side or the other. So there's several things you could do at this point. I would choose to get my x's together and make them positive. So I would subtract 4x, which that gives me 2x plus 9 equals negative 10. Subtract 9 from both sides. And 2x equals negative 19. Divide by 2. And x equals negative 19 halves. Which you could leave it like that, or how many times does 2 go into 19? 9. What's remaining? What? What's remaining? Negative 9 and 1/2. One's the remainder, is what I was trying to get y'all to say. Over 2. Or as a decimal, that'd be negative 9.5. I don't care which way you leave it. If I were going to graph this point where they intersect, I would probably want to see it as negative 9.5, but negative 19 halves takes too much thought to figure out where that is on the x-axis. It's easier to locate negative 9.5, right? Okay, so that's the x value of the ordered pair where function f and function g intersect. If I wanted to find the y value, I would take either function f or g, it doesn't matter, and I would substitute negative 9.5 into either function and solve for y. It doesn't matter which one you use, you're going to get the same answer regardless, okay? But it only asked me to find the x value, so I'm done with this one. Does anybody have questions on the first example? Okay. Example 2 on page 145. Consider the following system of equations. I have f of x equals 10 divided by the quantity of x plus 4, and I have g of x equals x plus 1 divided by x. And the directions say at what point or points do the graphs of f of x and g of x intersect. So if it wants to know the actual point, it wants to know the whole ordered pair. So I have to find x and then also find y. And if it intersects more than one place, then I'm going to have to find both of those places that it intersects, okay? So I need to know when function f equals function g. So just like I did before, I'll take what function x I'll take what function f is equal to, write that down, equals to whatever function g is equal to. So I have 10 divided by the quantity of x plus 4 equals x plus 1 divided by x. And if you want to put above it f of x equals g of x, and I just use substitution there like I did last time. So I have a system of rational equations, okay? We know to solve a rational equation, you want to clear the fractions. So first thing you do is make sure that you factor all of the denominators if possible. Can I factor either one of those denominators? Nope, can't. So I can go ahead and determine what the least common denominator is, which is what? X and x plus 4. Good. This x does not count. This x won't take into account that x. This binomial is all or nothing. Okay? I can't say, oh, well, there's already an x there. It doesn't count if it's a binomial. Monomial's different. So I'm going to multiply each term by the least common denominator. Reduce where I can, x plus 4 and x plus 4. On the right side, x and x. And we'll see what's left. In my first term, I have a x times 10, which makes 10x. On the right side, I have two binomials. I am going to have to distribute in order to get rid of the parentheses. Now, one of my classes told me that x plus 1 times x plus 4 is x plus 4. Is that correct? No. Oh, I'm sorry. They said x squared plus 4. Is that correct?
No.
No, they just did a quick check, first times first, last times last. Okay? Remember, if I have a binomial times a binomial, I got to do like the whole first, outer, inner, last thing. So we need to do that. On the left side, I'll just bring down 10x for now. Then on the right side, x times x is x squared. X times positive 4 is positive 4x. Positive 1 times x is positive 1x, or just positive x. Positive 1 times 4 is positive 4. Now, before I decide if I want to get it set equal to 0 or try to solve for x, on the right side, there's some like terms I can combine. So I'm going to do that before I start moving stuff over. So I have 10x equals x squared. And then plus 4x and plus x make plus 5x plus 4. Am I going to be able to just isolate x, or am I going to have to get it set equal to 0 and in standard form? Set equal to 0, because I've got quadratic terms and linear terms, right? So I'm going to bring the 10x over to the right side so that I have 0 on the left. On the right, bring down the x squared. Positive 5x minus 10x make negative 5x. And bring down the positive 4. So now I have a quadratic. I have to solve for x. Remember, if it's a quadratic, I can try to solve by factoring. And then once I factor, set each factor equal to 0. But does factoring always work? No. What does always work is quadratic formula or completing the square. So if factoring doesn't work, you're going to have to try something else. So hopefully I can factor this. So, does it have a greatest common factor? Nope. What is A? 1. What is B? And what is C? I'm going to need two numbers that multiply together to get A times C, which is positive 4, and add together to get B, which is negative 5. Alright, let's see. Negative 4 times negative 1 is positive 4, and negative 4 plus negative 1 is negative 5. So that gives me x minus 4 and x minus 1. Do I need to divide and slide? Nope, because a is 1. I mean, I can divide and slide, but if I do, is it going to change anything? No. Okay, so have I solved for x yet? Nope. What do I do at this point? Do I want to multiply them all back together? No, because that will leave me where I started, right? Set equal to 0. So x equals positive 4 and x equals positive 1. Are either of those extraneous? Is 4 extraneous? If I substitute in a 4, does 4 plus 4 give me 0? No. And if I put in a 4 there, I'm good. If I plug in a 1 or substitute in a 1, am I going to get a 0 anywhere? Okay. So those are the x values of the solution. That means that your functions intersect 2 times because I have 2 values for x. That's not an ordered pair 4, 1. They're both x values, okay? An ordered pair has to have an x value and a y value. So, we know how to do this. Say I'm going to find the ordered pair when x is equal to 4. Take either function f or function g. It does not matter which one. You're going to get the same answer for both. Plug in a 4 wherever you see an x and simplify. That'll give you your y value. So let's do that first. Well, actually, I'm going to write little directions. We need to find the y value of each ordered pair. Substitute each x value into either function f or function g. You all right? I didn't mean to put a question mark looking thing, I just meant to put a period. So I could substitute one into function f and one into function g, or I could substitute both of them into function f or both of them into function g. It doesn't matter. You're going to get the same thing, okay? So I'm probably just going to use function f for both of them. It does not matter. So function f was f of x equals 10 divided by the quantity of x plus 4. And at this moment, I'm finding when x is 4. So I'll do f of 4 equals 10 divided by 4 plus 4 gives me 8. So I'm just running out of room down here. 10 eighths reduces to 5 fourths, which is 1 1/4 or 1.25. So that ordered pair is 4, 1 1/4. When x is 4, y is 1 1/4, 1 25/100, 5 fourths, 1 1/4. What ifs? But I had another value for x, so this function is going to intersect twice. I have to do the same thing for the other one, and I'll just use function f again. Like I said, it doesn't matter. Give myself a little more room. And function f is f of x equals 10 divided by the quantity of x plus 4. This time I'm substituting in 1. So 1 plus 4 is 5, and that reduces to 2. So that ordered pair says when x is 1, y is 2. So I have 2 ordered pairs here. Do we have questions on that? Questions? Yes.
You plug 4 and 1 into
Mhm.
F.
Mhm. Or G if you want. I used F. Yep.
Makes them above.
Hmm?
We do above.
Yep. Because it's the ordered pair where they have in common. So no matter which one you substitute it into, you're going to get the same thing because they have that point in common, or in this case, points. Coolio? One more. Page 146. Example 3. Consider the following system of rational equations. Kind of speed it up a little bit on this one. G of x equals 36 divided by the quantity of x squared minus 9. And h of x equals 2x divided by the quantity of x plus 3. And the directions say at what point or points do the graphs of g of x and h of x intersect?
Does not agree with different variables if I wrote x. I mean,
Mm-mm. As long as it all matches up. Justify your answer algebraically.
this really just how you answer algebraically just
Show me the math. Don't just put it in your graphing calculator and trace to find that ordered pair. You know what I mean? Like prove it with math. So I'm going to set function g equal to function h. And I'm going to factor any denominator that I possibly can. Can I factor x squared minus 9? Yeah, it is a difference of squares. We can factor that easy. We don't even need a t-chart divide and slide, right? So it will be what? X plus 3 times x minus 3. On the right side, can we factor x plus 3? No. All right. So what is my least common denominator? X plus 3, x minus 3. Boom. So I'll multiply every term by the LCD. And cancel where I can or reduce. On the left side, I'm left with 36 equals. On the right side, I have 2x and x minus 3. I'll have to distribute that 2x to x minus 3. Okay? So I get 36 equals 2x squared minus 6x. Am I going to be able to isolate x or set equal to 0? Set equal to 0. Because I have a quadratic term and a linear term. The what? Distribute. So I have 0 equals 2x squared minus 6x minus 36. Set equal to 0, and it's in standard form. It's a quadratic, so if I didn't even want to try factoring, I could just go to quadratic formula or completing the square. But I prefer factoring if possible. So I'm going to try and factor over here on the side. Is there a GCF? It is 2. So we're going to factor it out. So that means I got to divide every term by 2. And what's left when I factor it out?
X squared plus 3x minus 12.
Close. It's x squared minus 3x minus 18. That's half of 36 is 18. So now we know A is 1, because I'm not factoring the original anymore. I'm factoring what's in parentheses. B is negative 3. And C is negative 18. So I need two numbers that multiply together to give me negative 18 and add together to give me negative 3. Negative 6 times positive 3 is negative 18. Negative 6 plus 3 is negative 3. So we have, run out of room, 2 times x minus 6 times x plus 3. And do we need to divide and slide? No, because remember, you're not looking at the original A. That's not what I'm factoring anymore. I'm factoring x squared minus 3x minus 18, where A is 1. And if A is 1 and we divide by 1, it's not going to change anything. But, bless you, have I solved for x? No. How many solutions should I have? 2, because I have 2 degrees. So, but I have 3 factors. Am I going to get 3 solutions from those 3 factors? If I set 2 equal to 0, is that true? No. So 2 is a factor, but it doesn't give me a solution, right? I can only get solutions when I have factors that have variables in them. So my solutions are positive 6 and negative 3. Are either of those extraneous? If I substitute 6 in up here where I have everything factored, am I going to get a 0 anywhere in the denominator? No. If I substitute negative 3, I will, right? Because right here, negative 3 plus 3 is 0. When I multiply by anything, I'm going to get a 0. So, is negative 3 a solution? Do I need to find its corresponding y value? No. This is extraneous. I'm sorry? No. That could have been a negative 10. So the only thing I have to find the corresponding y value is when x equals 6. Okay? So does it matter if I use function g or function h? No, I'm just going to use function h. And I'm substituting in a 6. So h of 6 equals 2 times 6 over 6 plus 3. So 2 times 6 is 12 over 9, which reduces to 4/3. Or you could... What? What did I mess up on? Alright. 4/3, or you could write 1 and 1/3, or approximately 1.3, doesn't matter. But your answer is the whole ordered pair. When x is 6, y is 1 and 1/3, or 1.3, or 4/3, whatever you want to say. So if it asks you for the point where it intersects, you got to find the x and the y. Okay? Does anybody have questions on that? Comments or concerns? Okay.